Hi everyone, this is video 5 and today we're going to be talking about designing functions, logic operators, and testing. It's really important that you design your functions well so that programming becomes much more easy. Every function should have one unique job, and if functions feel like they're doing too many things at once, split it into multiple functions. This is a really good way to modularize your programs. And as always, make sure that you don't repeat yourself. Anytime you feel like you're repeating code or copy and pasting code, that means that you can possibly make a function definition out of it. Every function should also have a very specific docstring that provides a brief description of what the function does. And I'll show you how this is useful in a couple examples. The next question we're going to try to answer is, how do we know that a function is correct? And it might seem easy with the functions that we've defined so far, like square, where we can just do a bunch of examples on the interpreter and make sure that's right. But it's actually quite a deep philosophical question. And it actually has a lot of research behind it. And one good thing that we can do is we can write doc tests. And I'll show you what those are. And before we talk about test-driven development, I want to show you specific examples of doc tests. Okay, so let's open up our text editor and open up our terminal. So I'm already in the directory, and I'm going to introduce doc tests with a function we've seen many times, squaring a number. And we know that the way to code this is just simply x times x. That's great. And so, as always, remember, when we define functions, it's always good to have a docstring, okay? And what we're going to say is it returns the square of a number, okay? So, now you might wonder, hey, what's the use of a docstring, okay? And I will show you an example of why it's useful. So I'm going to basically run Python on this file. And let's say, so I know what square is right now, but let's say for whatever reason I forget what square does. There's this built-in function called help that you can call on a name of a function, and it'll actually tell you exactly what square does. And so look at this. It says square x. Well, it answers my question of what does it do. It returns the square of a number. And bam, it's really easy. Okay? So in large projects, it's useful to, especially when other people are coding with you, and you've defined some function some way, it's good to have this documentation because they can just basically pull this up on the interpreter and they can see what's going on. So this is pretty useful. Okay, and now I'm going to show you something that's even more useful. It's called testing, writing doc tests. Okay, so how do we write a doc test? Well, we kind of emulate this interpreter style with the 3 greater than signs. And then let's say I want to call square on 5. What should I expect? 25. I want to run square on 10. I should expect 100. Let's call it on a negative number. Square on -7 should get 49. And let's also call it on 0. We should get 0. So this is some pretty good tests. And how we run doc tests is we actually run it using this special command. It's called python-m doctest video5.py. Okay, so this is something you just have to know, and what happens is nothing. So it's kind of anticlimactic, but this actually tells us that it worked. All our tests passed. And if you want to see a detailed overview of exactly how this works, so we can run it with a -v flag at the very end, and it'll give us a full representation of exactly what happened while we were testing. Okay? So square 5, it expected 25, it got 25. Expected 100, got 10. So whenever it says okay, that means it got what it was looking for. And at the very end, we have a good summary of what's going on. So it says 4 passed and 0 failed. That's awesome. Okay, so now let's see what happened if I had an error in my code, error in my logic. Okay, so obviously this is not squaring something. So let's see what happens when I run my doc tests. What's going to happen is everything fails. So it specifically tells you what failed. Hey, I expected 25, I got 26. I expected 100, I got 101. I expected 49, I got 50. So now you see a general pattern, and now you can easily, hey, I know everything's has an extra 1 to it, and bam, I can I can easily figure out what's going on, and then I can run it again, and it should work easily. So yeah, this is quite a trivial example, but when you're working with larger programs and more complex functions, it's good to always have doc tests. Okay, so now let's go into test-driven development. So test-driven development is a programming philosophy where you basically start by adding tests. Okay, and then the first thing you're going to do is to make sure that your tests are correct. You want to watch them fail without writing any code. So these tests should fail, right? Because you haven't written any code. And then now you write code. And then after that, you run tests, make sure they pass, and then you can refactor your code. Refactoring just means, hey, I can make my function definitions a little clearer. I can make it a little more concise. I can modularize a little more abstraction here and there. So, and then you test again. So it's kind of like a little game where you watch it fail and then you write to make it pass. Some people like this philosophy. Personally, I've never used it too much, and a lot of my friends that code also don't use it too much. But a lot of people in the industry do see it as a very good philosophy to use, and it writes good programs generally. So I will actually do an example of doing test-driven development, and we're going to use it to define a very complex function called cube of x. Okay, and what we're going to do is we are going to first write our docstring, right? Returns the cube of a number, and the first thing we're going to do is we're going to write our doc tests. So cube of 3 should give us 27. Cube of 10 should give us 1,000. Cube of -7 should give us -343. And let's do cube of 0 as well. Should give us 0. Okay. So there's our test. What's the first step of test-driven development? We make sure they fail. So I'm going to run it like this, and I get 4 failures as expected. So, and it's pretty cool in how it gives you a very detailed example of what's going on. For example, it tried cube of 3, got expected 27, but got nothing. Obviously, it got nothing because we haven't written anything. And also, notice that I run it without the -v flag, because when you're programming, generally, you only want to work with your errors, because if you write it with the -v flag, you just have a lot of input. And it's not exactly sure, it's kind of harder to figure out what exactly is going on. So that's why I recommend that you run it without the -v flag. And if you want to see an overall summary of what exactly happened after you pass all your tests, it's good to run with -v. But when you're going through and writing code and doing this test-driven development process, make sure you use the doc test running idea without the -v flag. Okay, so now let's write our code. So this is pretty simple. We just return x times x, save it, and now we are going to run the doc test again. Oh, what the heck happened? Okay, so obviously we didn't expect this to fail, but clearly I missed something, so it actually happens that my test was wrong, so I gotta make sure that's right, and that's all it is. So again, the cool thing about tests is they're an easy way to show you your mistakes, because you are gonna make mistakes while you program. It's just gonna happen. So I made a simple mistake right there, and this one showed me that pretty quickly. Okay, so now what's the next step of test-driven development? Refactoring your code. So let's say I don't like this whole x times x times x. Well, there's a better way to write it. I can just do power of x times 3. I can use the built-in function. Okay, and so now once I refactor it, hey, I have my test to make sure my refactoring didn't make it lose its functionality, and bam, that's all I have. So that's the entire test-driven development process. So now you've finished this function. Now you can move on into something else you have to do. So this is a cool thing about test-driven development. It's like a very structured way to write programs, and it usually limits the amount of errors that you make.